Chapter 4, Section 7, Missing Data Imputation, Part 2, KNN Imputation. In the previous section, we learned a simple method for imputing missing data using representative values such as mean, median, and mode. These methods assume that the occurrence of missing data is completely random. However, if there is some pattern to the occurrence of missing data, it is more effective to predict the values of each missing data based on the pattern. As such methods, this section explains machine learning-based methods for missing data imputation. As you already know, there are three mechanisms for missing data: MCAR, MAR, and MNAR. The simple imputation method we discussed in the previous section assumes that the missing data is MCAR. In other words, it assumes that the occurrence of missing data is completely random. However, assuming that the missing data is MAR is generally preferable, even when we do not know exactly how it occurs. MAR is the assumption that there is some relationship between the variable with missing data and other variables. When we deal with MAR cases, it is desirable to use a method of imputation that predicts the value of the missing data using the values of other variables. Typical imputation methods for MAR cases are KNN imputation, regression imputation, and multiple imputation. In this section, I will explain KNN imputation. K-nearest neighbors, KNN for short, is a supervised learning technique that can be used to predict values and categories. KNN imputation uses KNN to predict the actual values of missing data based on information from other variables, and then impute the missing data with those predicted values. I will give you detailed explanations of KNN in later chapters, but let me provide a brief overview here. The KNN imputation predicts missing data based on the similarity between data points. This similarity is quantified using Euclidean distance or Manhattan distance. The K in KNN signifies the number of data points that are used as the basis for the prediction. For example, if K is set to 3, the KNN model will select the 3 data points that are closest to the data point containing the missing data. That is, the 3 data points with the highest similarity. The KNN model will then estimate the value of the missing data based on the information from these 3 closest data points. Let's take a look at a simple example of the KNN method. Suppose we have this employee dataset. It contains data on motivation, stress, and job satisfaction, measured on a scale of 1 to 7. Here, the data on job satisfaction is missing for one employee. Let's visualize this data as a scatter plot. Take motivation on the horizontal axis and stress on the vertical axis. Plot each employee as a dot in a location corresponding to its motivation score and stress score. Let's input the job satisfaction score into the dot that represents each data point. The red dot represents the data point for which satisfaction is missing. Here, we set K to 3 and use the KNN method to estimate the job satisfaction of the red data point. We identify the 3 data points that are closest to the red data point based on the Euclidean distance between the values of motivation and stress. We can identify these closest data points by gradually enlarging the circle centered on the red data point. These 3 points are the nearest points. Then, average the job satisfaction of these 3 nearest points. This average value is the estimated value for the missing data. When the missing data is numerical, the average value is used as the estimated value. When the missing data is categorical, the category that accounts for most of the 3 neighboring points is used as the estimated category. Therefore, when there are many categories, it is better to use a larger number of neighboring points, that is, a larger value for k, to make the majority decision meaningful. Let's implement KNN imputation by Python. Let's use this simple dataset as an example. As we can see, this dataset has missing values for 1 or more variables. By using Python's KNN imputer, we can implement KNN imputation efficiently. Let's explore how to do it below. First, import pandas and NumPy. And import KNN imputer from scikit-learn impute. Then, create a dataset. Next, initialize the KNN imputer. The default setting is k equals 5. So, here, we specified k equals 3. Set k to 3 with n underscore neighbors equals 3. Please note the name of the argument. It is n underscore neighbors, not k. Store the initialized KNN imputer in a variable called KNN underscore imputer. Next step is imputation. Apply fit transform to the initialized KNN imputer to implement mean value imputation to the entire data frame. By putting the entire data frame inside the brackets of fit underscore transform, we can impute all missing values in this data frame df. It enables us to impute missing values in all columns of the data frame at the same time. However, when we apply fit underscore transform method to the data frame will be converted to a NumPy array. So let's apply pandas data frame method to convert it to a data frame. When the data was converted to a NumPy array, the information of index and column names were deleted. So, setting arguments of columns and index, assign the column names and index of the original data frame. Then, store the imputed data frame into a variable named df underscore imputed. Let's display the imputed data frame. As we can see, the missing data was imputed, and now there are no missing values. The values predicted by KNN were imputed to the cells that were missing values. KNN imputation uses KNN, a machine learning algorithm, to estimate the value of missing data from other variables. By using machine learning to estimate the values, it is possible to estimate imputed values that are closer to the actual values than mean or median imputation, when other variables influence the variable containing the missing data. Using KNN imputation and imputed data can ultimately improve the prediction model's performance. Besides, we can implement the KNN imputation using simple code from Python libraries. However, it is important to know that the performance of KNN depends on the value of k, which is the number of neighboring points and the distribution of the data. In addition, we must recognize that the estimated value contains uncertainty because it is not the actual value. Thank you for watching. Please thumbs up and subscribe to my channel.